Good afternoon, students. Today we start with the new chapter, that is mechanical. Right. For board exam, from this chapter, the marks allotted one question for 1 marks and one question will come for 3 marks. Right. So this is the weightage of the chapter for your board exam. Right. So only for 4 marks ಇದೆ. So lengthy derivations ಆ ಥರ ಯಾವುದೂ ಇಲ್ಲ. So small concepts ಇರುತ್ತೆ. So similar to that of the previous chapter. Right. So this is about the marks weightage. Right. So what are fluids? Right. And gas ಬರುತ್ತೆ ಜೊತೆಗೆ liquids ಬರುತ್ತೆ. Right. So liquids, that one has fluids, right? So gases ಮತ್ತೆ liquids, so combined together we call that one as fluids, right? So how we define fluid, right? So fluids are the substances, right? So fluids are the substances, right? So fluids are the substances that move or that flow under the applied force and it does not have any regular shape, right? So how we define fluid? So fluids are the substances that flow under the action of the applied force, right? So these either liquids, so fluids ಅಲ್ಲಿ ತಕ್ಷಣ ನಾವು ಅದನ್ನ liquids ಆದ್ರೂ ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು ಅಥವಾ gases ಆದ್ರೂ ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು, right? So how we define fluids? So fluids are defined as, so it is defined as, so these are the substances, right? So fluids are the substances that flow action of, under the action of force. So fluids are the substances that flows under the action of the applied force, right? So shape, right? So fluids does not have any definite shape. So ಇದನ್ನ ನೀವು ಆಲ್ರೆಡಿ ಹೈಯರ್ ಕ್ಲಾಸಸ್ ಅಲ್ಲೇ ಸ್ಟಡಿ ಮಾಡಿರ್ತೀರಾ, ರೈಟ್? ಸೊ ನಾವು ಇವಾಗ ಒಂದು ವಾಟರ್ ನ ಗ್ಲಾಸ್ ಅಲ್ಲಿ ಹಾಕಿದ್ರೆ ಇಟ್ ಅಟೈನ್ಸ್ ದ ಗ್ಲಾಸ್ ಶೇಪ್. ಸೊ ಬೀಕರ್ ಹಾಕಿದ್ರೆ ಬೀಕರ್ ಶೇಪ್ ಅಲ್ಲಿ ಬರುತ್ತೆ, ರೈಟ್? ಸೊ ಫ್ಲೂಯಿಡ್ does not have any definite shape, right? So fluids andre fluids alli nಮಗೆ we are going to study in this chapter, that is mechanical properties of fluids ಅಂತ study ಮಾಡ್ತಿದ್ವಿ. ಅಂದ್ರೆ combined together we are going to discuss on the liquids and as well as on the gases. So ಇವೆರಡನ್ನು together ಆಗಿ one word ಕೊಟ್ಟಿದ್ದೀವಿ. So ಆ word ಏನು ಅಂದ್ರೆ fluid, right? So how we define fluid? So fluids are the substances, so these substances will flow under the action of the applied force. So applied force ಇದ್ರೆ ಇವು ಏನಾಗುತ್ತೆ, ಮೂವ್ ಆಗುತ್ತೆ, that means flow ಆಗುತ್ತೆ. So ಅಂತದನ್ನ ನಾವೇನಂತ ಕರೀತಿದೀವಿ, fluids. So substances will move under the action of the applied force, so those we call as the fluids, right? So these fluids does not have any definite shape, right? So in this chapter we are going to study the fluids in two categories, that is when fluids are at rest and also when the fluids are in motion. So fluids rest ಅಲ್ಲಿ ಇದ್ದಾಗ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ, ಜೊತೆಗೆ fluids motion ಅಲ್ಲಿ ಇದ್ದಾಗ ಕೂಡ ನಾವು ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ, right? So that the study of fluids at rest, right? So that we call as hydrostatic, right? So hydrostatic is a branch of mechanics. So that is especially we are going to discuss about the fluids, that is study of fluids at rest. So fluids rest ಅಲ್ಲಿ ಇದ್ದಾಗ ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇದೀವಿ. ಸೊ ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ, ಹೈಡ್ರೋಸ್ಟಾಟಿಕ್, ರೈಟ್? So in the name itself mentioned static. Static means at rest, right? So the study of fluids at rest, right? So same as the study of fluids in motion. So aduna ನಾವೇನಂತ ಕರಿತೀವಿ, ಹೈಡ್ರೋಡೈನಮಿಕ್ಸ್, right? So what is hydrodynamics? So hydrodynamics is the study of fluids in motion, right? So in this chapter we are going to discuss the fluids at rest and also the fluids in motion, right? So this is a brief introduction about the chapter. There is mechanical properties of fluids, right? So definition of the fluids. So definition, how we define fluids means, so these are the substances which flows under the action of the applied force, so that we call as the fluids, right? So fluid does not have any definite shape. So ಇದು ಒಂದು property ಅಥವಾ property ಅಂತಾನೆ consider ಮಾಡಬಹುದು, right? So fluid does not have any definite shape. So in this chapter we are going to discuss the fluids. So ಇಲ್ಲಿ fluids ನ ನಾವು ಎರಡು ತರ ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇದೀವಿ. ಒಂದು when the fluids at rest, so static ಅಲ್ಲಿ ಇದ್ದಾಗ ಫ್ಲೂಯಿಡ್ಸ್ ಬಗ್ಗೆ ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇದೀವಿ. ಸೊ ಅಂತ ಬ್ರಾಂಚ್ ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ, ಹೈಡ್ರೋಸ್ಟಾಟಿಕ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಸೇಮ್ ಫ್ಲೂಯಿಡ್ಸ್ ವಿಚ್ ಆರ್ ಇನ್ ಮೂವಿಂಗ್, ಸೊ ಮೂವ್ ಆಗ್ಬೇಕಾದ್ರೆ ನಾವು ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇದೀವಿ. ಸೊ ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ, ಹೈಡ್ರೋಡೈನಾಮಿಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ, ರೈಟ್? ಸೊ ಸ್ಟಾರ್ಟ್ ವಿತ್ ಪ್ರೆಷರ್. Right? The force which is acting perpendicular or normal to the surface area per unit surface area, normal to the surface area, that is per unit area, right? So normally per unit surface area, that we call as the pressure, right? So in the last chapter also we discussed the force which is acting normally to the area of cross section or area, so that we call as the stress. So same here we are going to discuss about the pressure. So ಎರಡಕ್ಕೂ ಕೂಡ ಸೇಮ್ ಡೆಫಿನೇಷನ್ ಬರುತ್ತೆ, ಬಟ್ ಅಲ್ಲಿ ನಾವು ಸಾಲಿಡ್ಸ್ ಅಲ್ಲಿ ಅದನ್ನ ಸ್ಟ್ರೆಸ್ ಅಂತ ಕರೀತಾ ಇದ್ವಿ, ಬಟ್ ಇನ್ ಫ್ಲೂಯಿಡ್ಸ್ ಅಲ್ಲಿ ಅದನ್ನ ನಾವು ಪ್ರೆಷರ್ ಅಂತ ಡಿಫೈನ್ ಮಾಡ್ಕೊಂತೀವಿ, ರೈಟ್? ಸೊ the magnitude of force acting normally or perpendicular. So normal ಅಥವಾ perpendicular ಎರಡಕ್ಕೂ ಕೂಡ same meaning, right? To the surface of an object per unit area of area of cross section acting per unit area, right? So that is the definition of the pressure, right? Per unit area of an object, right? So ಯಾವ ಆಬ್ಜೆಕ್ಟ್ ಗೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗಿದೆ, that is in fluids, so ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ, ಪ್ರೆಷರ್ ಅಂತ ಕರಿತೀವಿ, right? So again pressure is equals to force divided by area, right? So force is the normal force, that is perpendicular force which is acting per unit area, right? So per unit area dalli force perpendicular ಆಗಿ ಆಕ್ಟ್ ಆಗ್ತಾ ಇತ್ತು ಅಂದ್ರೆ, ಸೊ ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ, ಪ್ರೆಷರ್. ಸೊ ಸಾಲಿಡ್ಸ್ ಅಲ್ಲಿ ಅದನ್ನ ಸ್ಟ್ರೆಸ್ ಅಂತ ಕರಿತಾ ಇದ್ವಿ, ಸೊ ಫ್ಲೂಯಿಡ್ಸ್ ಅಲ್ಲಿ ಇದನ್ನ pressure ಅಂತ ಕರಿತೀವಿ. So ಎರಡಕ್ಕೂ definition same. So the force which is acting perpendicular to any object, so that object per unit area, so that we call as the pressure, right? So this is the mathematical relation. So P is equals to F divided by A, right? So P is equals to F divided by A, where A is the area and F is the force, right? So next, it is a scalar quantity. It is a scalar quantity, right? So it's SI unit. So SI unit, again force ge Newton, area ge meter square, so that is Newton per meter square. N m to the power minus 2. But here in pressure, we regularly use the unit that is Pascal, right? So 1 Pascal is equals to 1 Newton per meter square. So Newton per meter square andrunu onde, Pascal andrunu onde. So pressure alli we generally use the word that is Pascal. So unit na yav use ಮಾಡ್ಕೊಂತೀವಿ Pascal, that is PA. So word alli represent ಮಾಡಬೇಕಾದ್ರೆ P small letter ಅಲ್ಲಿ ಇರಬೇಕು, letters alli represent ಮಾಡಬೇಕಾದ್ರೆ P. So that is PA, right? So 1 PA is equals to 1 Newton per meter square, right? So 1 PA is equals to 1 Newton per meter square. So ಎರಡು ಕೂಡ SI unit. So either we can use Newton per meter square, but generally we use the word that is Pascal. So pressure ಗೆ ನಾವು Pascal ಅಂತಾನೆ unit ನ use ಮಾಡ್ತೀವಿ, right? So it is a scalar quantity and its SI unit, then dimension, right? So dimension of a pressure, so dimension of the pressure is equals to the dimension of the stress. So here is equals to the dimension of the stress. So here two physical quantity is same dimension, that is m L power minus 1 T power minus 2, right? So pressure is the magnitude of the force. So for example, if we have considered any one area, so onto this area the force which is acting perpendicular. So ಈ surface area ಗೆ force perpendicular ಆಗಿ act ಆಗ್ತಾ ಇರುತ್ತೆ. So ಅದನ್ನ ನಾವು ಏನಂತ ಕರಿತೀವಿ, pressure ಅಂತ ಕರಿತೀವಿ, right? So P is equals to F divided by A. So force which is acting perpendicular to the area that we call as the pressure, and it is a scalar quantity. Its SI unit is Pascal or Newton per meter square. So its dimension is m L power minus 1 and T power minus 2, right? So next, expression for the pressure at a point in a fluid, right? So pressure here, we need to find the pressure at any point inside the fluid, right? So either fluid, right? So either we can take that one as in gaseous or we can take that one in liquids. So here we are going to, so each after the maximum we are going to use the liquids, right? So gases liquids na ಜಾಸ್ತಿ use ಮಾಡ್ಕೊಂತಾ ಇದ್ದೀವಿ, right? So pressure at a point inside the fluid, right? So ಎಲ್ಲ ಕಡೆಗೂ fluid ಅಂತೆಲ್ಲ ಮೆನ್ಷನ್ ಮಾಡಿ, ಬಟ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂತಾ ಇರೋದು ನಾವು liquid ಅಂತ ತಗೊಳ್ತಾ ಇದ್ದೀವಿ, right? So liquid ಅಥವಾ in general we take that one as fluid, right? So we need to find the pressure at any point inside the fluid. So ಯಾವುದೋ ಒಂದು fluid ಇದೆ, so fluid ಒಳಗಡೆ ನಾವು pressure ನ find out ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ we need the relation, so that we are going to derive here, right? So to find the expression for a pressure inside the fluid, so consider one vessel or a container, right? So this is one vessel or a container, right? So this is one vessel, right? So in this vessel it contains the liquid of density rho, right? So consider one vessel, right? So this vessel consists of a liquid. So this liquid has a density rho. So liquid having, or we generally take a fluid having density rho, right? So one vessel na consider ಮಾಡ್ತಾ ಇದೀವಿ. So a vessel ಒಳಗಡೆ we are considering one fluid. So either it may be liquid or gases. So ಇದರಲ್ಲಿ ಯಾವುದನ್ನು ಬೇಕಾದರೂ ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು. So here in general we taken that one as fluid. So that fluid having the density rho. So fluid ಗೆ density ಇರುತ್ತೆ. So that we denoted by rho. So density is denoted by rho and the density is defined as mass by volume. So mass divided by volume na ನಾವು density ಅಂತ ಕರೀತೀವಿ, right? So consider one area of cross section A. So inside the liquid we consider one area of cross section A, right? So that area of cross section is at a depth h from the surface of the liquid. So this is the surface of the liquid. So from the surface of the liquid it is at a depth. So ಎಷ್ಟು depth ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ h ಅಷ್ಟು depth ಅಲ್ಲಿ ಇದೆ, right? So first we considered one vessel, right? So first we considered one vessel contains the liquid or fluid. That vessel contains the liquid or fluid or gas, right? So that fluid has the density rho, right? So after that consider one area of cross section A which is at a depth h from the surface of the liquid. So surface of the liquid in the ಎಷ್ಟು depth ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ h ಅಷ್ಟು depth ಅಲ್ಲಿ ಇದೆ, right? So ಅದನ್ನ ನೀವು ಯಾವುದನ್ನು ಬೇಕಾದರೂ ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು. So here we taken that one as h, right? So onto that surface area we consider one volume element or conical element. So the cylindrical element. So volume element ಅಥವಾ ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು ಅಥವಾ ಅಲ್ಲಿ cylindrical element ಅಂತ ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡಬಹುದು. So that is in the cylindrical shape. So cylindrical element ಅಥವಾ volume element so ಯಾವ shape ಅಲ್ಲಿ ಇರುತ್ತೆ ಅದನ್ನ ನಾವು that is as you wish. So here we take as you wish. So here we take area of cross section in circular, right? So hence we are taken the cylindrical volume element, right, of length h. So cylindrical volume element na ನಾವು ಕನ್ಸಿಡರ್ ಮಾಡ್ತಾ ಇದೀವಿ. So this is from the surface. So length of the cylindrical element ಎಷ್ಟಿದೆ, that is volume element ಎಷ್ಟಿದೆ ಅಂದ್ರೆ h ಇದೆ. So area of cross section ಎಷ್ಟಿದೆ, a ಇದೆ, right? So this is the consideration, right? So ಇದು ನಮಗೆ imaginary volume element. So ಇದು exist ಇರೋದಿಲ್ಲ. We are consider one imaginary element, that is the volume element, right? So volume element ಅಂದ್ರೆ again it is 3 dimensional, right? So what we did means first we considered one vessel or a container. So that container consists of a fluid having the density rho, right? So after that consider one area element A. Onto this area element A, that is at a depth h from the surface of the liquid or fluid. So fluid ಎಲ್ಲಿ surface ಇದೆ, so ಆ surface ಇಂದ ಎಷ್ಟು depth ಅಲ್ಲಿ ಇದೆ ಅಂದ್ರೆ h ಅಷ್ಟು depth ಅಲ್ಲಿ ಇದೆ, right? So next onto this area element we consider one volume element of length h. So exerts a force onto this volume element. So ಈ fluid ಇದೆ. So ಈ fluid ಈ volume element ಮೇಲೆ ಏನು ಅಪ್ಲೈ ಮಾಡ್ತಾ ಇದೆ, that means it exerts the force. So force ನ exert ಮಾಡ್ತಾ ಇದೆ, right? So that force is in all the direction ಅಲ್ಲಿ ನಮಗೆ ಏನು exert ಆಗ್ತಾ ಇದೆ, force exert. So in the plant right? So the fluid which contained in the vessel exerts the force on this volume element. So ಈ volume element ಮೇಲೆ ಏನು exert ಮಾಡ್ತಾ ಇದೆ, force exert ಮಾಡ್ತಾ ಇದೆ, right? So red color ಅಲ್ಲಿ ಮೆನ್ಷನ್ ಮಾಡಿರೋದು ಎಲ್ಲದು ಯಾವುದು, force, right? So the fluid exerts the force onto the volume element, right? So force exert ಮಾಡ್ತಾ ಇದೆ. So vertically force is from the downward surface. So vertical force ಅಲ್ಲಿ ಎಲ್ಲಿ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ, ಏರಿಯಾ ಎಲಿಮೆಂಟ್ ಮೇಲ್ಗಡೆ ವರ್ಟಿಕಲಿ ಅಪ್ವರ್ಡ್ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ರಿಮೈನಿಂಗ್ ಓವರ್ ಆಲ್ ಕ್ರಾಸ್ ಸೆಕ್ಷನಲ್ ಸರ್ಕ್ಯುಲರ್ ಸರ್ಫೇಸ್ ಏರಿಯಾದಲ್ಲಿ, ಸೊ ಸರ್ಫೇಸ್ ಏರಿಯಾ ಮೇಲೆ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ. ಸೊ ಲೆಫ್ಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಆಕ್ಟ್ ಆಗ್ತಿರೋ ಫೋರ್ಸ್ ಮತ್ತೆ ರೈಟ್ ಸೈಡ್ ಅಲ್ಲಿ ಆಕ್ಟ್ ಆಗ್ತಿರೋ ಫೋರ್ಸ್ ಈಕ್ವಲ್ ಆಗಿ ಆಕ್ಟ್ ಆಗ್ತಿರೋದ್ರಿಂದ ಸೊ ನೆಟ್ ಫೋರ್ಸ್ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ನಮಗೆ ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. ಸೊ ಓನ್ಲಿ ದ ಫೋರ್ಸ್ ವಿಚ್ ಇಸ್ ಆಕ್ಟಿಂಗ್ in the downward direction. So downward direction, that is upward direction ಗೆ force act ಆಗ್ತದೆ. So that is the force F. So F is the force which is acting on the volume element. So F. So F is the force which is acting on the volume element. So ಈ volume element ಮೇಲೆ force act ಆಗ್ತದೆ. So fluid exerts the force in all the directions. So ಎಲ್ಲ directions ಅಲ್ಲೂ ಕೂಡ force apply ಆಗ್ತಾ ಇದೆ. But opposite and equal force ಇರೋದ್ರಿಂದ ಈ ಎರಡು ಫೋರ್ಸಸ್ ಏನಾಗುತ್ತೆ ನಮಗೆ cancel ಆಗುತ್ತೆ. So only the remaining force on to this volume element is in the cross sectional area, that is vertically upwards, right? So now this force is balanced downward. So the ಯಾವಕಡೆ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ, downward ಆಗಿ ಆಕ್ಟ್ ಆಗ್ತಾ ಇದೆ, right? So from this we can write the force on area of cross section A, right? So the force acting on the area of cross section A, that is equals to weight which is acting vertically downward direction. So equilibrium alida, so fluid volume element, right? So that we can write force of cross section A, that is equals to, so force on area of cross section A, that is equals to weight of the liquid in the volume element, right? So weight of the liquid contained in the volume element, right? So that is force F, that is equals to weight of the liquid. So weight of the liquid, that is denoted by M into G, right? So mass of the liquid into acceleration due to gravity, right? So this mass we can written in terms of density, right? We know density is equals to mass divided by volume. So density is denoted by rho. So mass is M, volume is V. So from this we can replace mass M, that is equals to rho into V, right? So density into volume. So here M, that is replaced by rho into V into, so cylindrical shape ಅಲ್ಲಿ area ಇದೆ ಜೊತೆಗೆ height ಇದೆ, so that becomes the volume, right? So F is equals to rho into H into A into G, right? So volume is replaced by H into A, right? So H into A, height into area, that gives what? The volume of the cylinder, right? So from this F, that is equals to A rho G H, right? So if we shift the A to the LHS, so that becomes F divided by A, that is equals to rho G H. So from the definition, pressure is defined as force which is acting perpendicular. So if you observe here, the force which is acting perpendicular to the surface area, right? So that is A, right? So we can write force by area, that is pressure P, right? So P is equals to rho G H. So at any point at a depth H, so E point ಅಲ್ಲಿ ಎಲ್ಲ ಕಡೆಗೂ inside the fluid the pressure will be the same, right? So that depends on H ಮೇಲೆ ಅಥವಾ ಗ್ಲಾಸ್ ಅಲ್ಲಿ ಹಾಕೋದು ಯಾವ್ದ್ರಲ್ಲಿ ಹಾಕೋದ್ರೂ ಅದ್ರದ್ದು ಡೆನ್ಸಿಟಿ ಏನಿರುತ್ತೆ remains constant ಇರುತ್ತೆ. So again acceleration due to gravity G is constant, so pressure is varies with the height, right? So pressure ಯಾವ್ದ್ರ ಮೇಲೆ vary ಆಗ್ತಾ ಇದೆ, height ಅಥವಾ depth. So here we consider that one as depth. So at this point, so e point ಅಲ್ಲಿ on this fluid at any point in the same height, so ಎಲ್ಲಾ ಕಡೆಗೂ ನಮಗೆ pressure ಎಷ್ಟಿರುತ್ತೆ, same ಇರುತ್ತೆ, right? So at a height h, the points inside the fluid at a depth h, the pressure will remain the same, right? So this is the expression for the pressure at a point inside the fluid. So inside the fluid ಅಲ್ಲಿ ಯಾವುದಾದರೂ ಒಂದು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ನಾವು ಪ್ರೆಷರ್ ನ ಫೈಂಡ್ ಔಟ್ ಮಾಡ್ತಾ ಇದೀವಿ ಅಂದ್ರೆ ಸೊ ದೇರ್ ವಿ ಆರ್ ಕನ್ಸಿಡರ್ಡ್ ಒನ್ ಇಮ್ಯಾಜಿನರಿ ವಾಲ್ಯೂಮ್ ಎಲಿಮೆಂಟ್. ಸೊ ಅಲ್ಲಿ ಒಂದು ಇಮ್ಯಾಜಿನರಿ ವಾಲ್ಯೂಮ್ ಎಲಿಮೆಂಟ್ ನ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಂತೀವಿ, ರೈಟ್. ಸೊ ಅಥವಾ ಅದನ್ನ ನಾವು ಲಿಕ್ವಿಡ್ ಕಾಲಮ್ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. ಸೊ ವಿ ಕಾಲ್ ದಿಸ್ ಒನ್ ಆಸ್ ವಾಲ್ಯೂಮ್ ಎಲಿಮೆಂಟ್ or liquid column. So adu imaginary agi consider ಮಾಡ್ಕೊಂಡು we can find the pressure at any point inside the fluid. So inside the fluid at any point we can find the pressure. So that is what, that is pressure is equals to density into acceleration due to gravity into height. So h is the depth, right. So aduna height alli the height consider ಮಾಡ್ತೀವಿ. So ಇಲ್ಲಿ depth ಇರೋದ್ರಿಂದ where h is the depth, right. So if we consider at any point here, if we need to find the pressure at this point, then we need to take here the height h dash. So again here we consider one cylindrical element or volume element, then we can find the pressure at that point. That is at a height h dash, that is depth h dash only we can find the pressure, right. So idu continue part ide, but tumma network problem aagta ide, so that we will continue in our next class, right. So that is gauge pressure. So that is the relative pressure with respect to the atmospheric pressure, right. So idu understand aaytu andre idu the continue part ide. So also the derivation kuda ide, right. So that we will discuss in our next class, right. Thank you.